Okay, so this problem here, perpendicular to the y-axis, those are slices, um, and the rectangle height is y over 2. Um, so let's just see, we're doing y's, we're not rotating, we're just looking at it like that. So let's see, this is going to be from 0 to 4. It's a rectangle, that's just b times h, and whose base lies in R. So that right there, that x value is the base. At each slice, that's just the x value. And then the height is y over 2, which was given to us like that. Okay. We need to figure out what x is, though, since I'm doing dy. So that would be y equals x cubed over 2. So 2y equals x cubed. And therefore, x equals cubed root of 2y. That's it. So let's just make that substitution. Cubed root of 2y times y over 2. And there we go. Yeah, we could mess around with some of that. I'm just going to leave it that way, though. Let's see. This is a rotation. No, expression. This is not rotation. So let's see. Y equals x is like that, and y equals x squared is like this. And this one's y equals x. Let's see. I got y equals x and y equals x squared. They cross at 1, 1, and it's 0, 0. See, says slices perpendicular to the y-axis. So those kind of slices right there, and they're all semicircles. So that's pi r squared over 2. Because of that. Let's see, and this is tough. We just want half of that. So like if this distance, which would be the right minus the left, so that's x squared minus x, that right there gives me this whole distance right here. Problem is I only want r, so I just want half of that. Okay, so you just gotta look at it and think about it. You want that length, but it's half of that to get you r. So let's see, we're doing 0 to 1 dy, so horizontal, and it's just pi r squared over 2, pi up front. Actually, I put pi over 2 up front, so r squared here. But each r is going to be x squared minus x over 2. And that's it. There's our integral for semicircles. Let's see, let R be the region enclosed by the x-axis. Graph y equals x squared, x equals 4, it's over here. So let's see, they would cross at 416, right? So that's x equals 4. 0. The x-axis, okay, so this is the shape right here that we're dealing with. Slice is perpendicular to the y-axis of horizontal, are equilateral triangles. So real quick, that area is, check that. Good, yeah. 4 a squared. And this is dy, so really we just need to know how we can express this length right here of each one. Well, each time would be this distance 4 minus this distance, which is x squared. Or no, sorry. It'd be just 4 minus x. So at each point on here, that's just the x value. So it'd be just 4 minus x. That would give me the one side. So that's the a value for this. But since these are horizontal and doing dy, I need to know I need to know how to put this in terms of y. So let's see, I look up here. X equals the square root of y. So it'd be 4 minus the square root of y. That's going to be that distance right here each time. So that's squared. Going from 0 to, now careful, doing horizontal. So this is actually going to 16. So let me put it all down here. 0 to 16 of 4 minus square root of y, all squared. Y, don't forget, of course, that it was square root of 3 over 4. Okay. Okay, now this one's a little tricky. If you were to graph this, let's see. Let's see, x minus 1, x minus 3 squared. Yeah, it's a fine looking shape. Okay. Oops, right. So kind of like this. Oh, it's there. Why is that? Around the y-axis, let's see, these points are 1 and 3. So 1, 0, and 3, 0. And around the y-axis, well, because this is one of those funny ones where we couldn't do washer on this, so we're going to use shell. And shell, if you think about unwrapping one shell, you end up with just a rectangle, rectangular prism. So let's see, and we just need 2 pi r, that's the radius, and then we just need the height. So the height of each one. So let's see, this is going to be from 1 to 3. This is the x values. Doing vertical slices, so it's dx. And yeah, it's just 2 pi r times h. 2 pi r times h. Okay, well, the r in this one would each time just be the x value. That's like the distance right here from each slice to the axes. So 1 to 3. I put 2 pi up front. R is just the x value conveniently. And the height is just going to be the height of each of these slices, which is the y value, which is going to be just that. And dx. Yep, so we got r, and that's the h value, and there it is. Let's see, square root of x. Y equals 4. Hey. Let's see. Doctor. So that's 16, 4. 0, 4. Around the y-axis. That's right here. So it looks like we could do shell, or we just do disk. So we do disk. So that's just pi r squared. So horizontal, it's dy, 0 to 4, pi up front, r squared, that would be, well, the r each time is just this x value. But we don't want that, we want something with y, so that would be, use this to give you y squared equals x. So it would end up being y squared, squared. Right. So I'll do that. Okay. And the x-axis, that's that 2, 6, 1, 3. Around the x-axis, so I'm going to use washer. Let's see, from -1 to 2. Let's see, the outside one's going to be x plus 4. So pi, or let's actually, let me keep pi on the inside of this. Pi r squared minus the inside one, which is x, so minus pi squared plus 2 squared that's it.